this is the expected results. So click D, move from one place to another. Okay, so what we have in the workspace is basically a folder named lab. Inside this lab folder, we're gonna have this model, and inside this model, we're gonna have the panel 0, which is this one, anchored, is no more than a part anchored. Same with the panel 1. We're gonna have the rail, is the part that we're gonna add the prismatic, and we're gonna have the platform. We can check the collision as default, but in the case of the rail, we're gonna remove the can collate and we're gonna anchor it. Okay, so let's add a prismatic to the rail. We're gonna select the rail, we go to model, create prismatic. When we do that, the cursor is gonna change. So we're gonna select here, let's try to select this upper right corner, and the arrow should be pointing like outside. All of this face is gonna be pointing the arrow outside. If I move this, we don't want like this, we don't want like this, we want here. This arrow I'm trying to put in the corner. Okay, the next is here. We can place it here in the corner too. Okay, by doing this, now we're gonna see that the platform is gonna have the attachment 1, and the rail is gonna have an attachment 0 and the prismatic constraint. Let's play to check. Here, run. Okay, so if I select the platform and I try to move it, then I could be able to move the platform in this direction or this direction in this axis. But if I try to move in this, the platform goes back, or this other. So this is gonna constrain the platform to allow only movements in this axis. Okay, let's play a little more with the properties of the prismatic constraint. Okay, I'm gonna select the prismatic constraint. And here we have the actuator. We're gonna change it from none, we're gonna change it to servo. And now there are new properties. We're gonna change the servo max force to 100,000. The speed we're gonna change it to 1000. And in the target position is interesting because when I change this number, when I change this value, the platform is gonna move. So if I say let's try with the 20, the platform has moved. So positive number is gonna be from this point to the left, and negative number is gonna be from this point to the right. So if I change this to minus 20, you can see the platform is moving. So basically the range is from 0 to negative values if we want to keep the platform between these 2 points. So if I say, let's try with minus 30, let's find the value, maybe 40. Okay, 40. Let's try minus 35. I believe 35 is the value. With minus 35, we are finding the position. For you, maybe it's going to be different because of course, that depends of the length of this rail. Okay. So let's set up the prismatic constraint. We already saw in the test, we're gonna change this to servo. We're gonna define here max force to 100,000. We're gonna change the speed to 1000. Okay, we're gonna leave this as 0. The next is to add proximity prompts for this, for each of the panels. One proximity prompt from the other proximity prompt. Okay, so the logic is basically what we want to do now is that we're going to create the script, and the idea is that the user is going to click in the first panel, and then the platform should move to the other place. Being here, if the user clicks in the second panel, the platform should go back. This is the idea. Okay, so let's create a script here inside the model. I'm gonna create a script, and inside the script we want to, at the beginning, we want to take the proximity prompts. Let's place it here. Okay, so okay, just copy it. One and one. After doing this, we can do as and let's play here. And I'm gonna go here, right click, panel 1, panel 0, panel 1. Okay, so now let's take the prismatic constraint, which is here. So click, click. Excellent. With the E. Cool. So this is the idea of this tutorial. I hope you have learned how to do a moving platform. If you have any question, please let me know in the comments.